This is the second half of 4.1, so I labeled it 4.1b. That way we didn't have to do 14 topics in a single lesson. So this one deals with composition. So what does it mean to compose functions? So let's say I had an f function, and let's see, I know Adam lives in Castledale. Sage, where do you live? Cleveland. And Calvin, where do you live? Elmo. Anybody else live in one of these cities? Okay. And Kinley also lives in Elmo. Okay. So the f function takes a person and attaches them to the city that they live in. Okay. The only rule that a function has to follow is no person can live in two cities at the same time. You either live in one or you live in another. You can't live in both, right? So can multiple people live in Elmo? Yeah, that's totally fine. What if I had another function and I called it function g, and this function looked at where you lived and it attached it to your middle school? So Castledale and Orangeville kids go to San Rafael, Cleveland and Elmo kids go to Canyon View. Okay. Well, what if I wanted a function that looked at a person and then spit out the middle school that they attend? Okay. So combining two functions together is called composing the functions. And our operations in mathematics are addition, subtraction, multiplication, and division. And in fact, all of these are based off of addition, right? Subtraction is just addition of negatives. Multiplication is just repeated addition. Division is sort of like repeated subtraction. Exponents and square roots and everything else is based off of addition. And that's all computers know how to do. The only thing a computer knows how to do is add. And then using addition, we can teach it how to subtract. And using addition, we can teach it how to do multiplication and division and exponents and all the other computations that a computer does. Okay? Well, we can add, subtract, multiply, and divide functions if we wanted. So if I wanted to do q plus r of x, okay, this is the name of the function. That function's name is q, and the variable it's written in is x. That's what that means. Q of x just means function named q written in the variable x. We can always replace that with y and graph it. Y equals negative x, or y equals negative x squared plus 1, and graph it. So this is the name of a new function. Oh, not g, q. So I want to build a new function whose name is q plus r. Well, how do you think we create that function? It's really easy. We do q of x plus r of x. So this is the name of the new function, and this is the instructions on how to build it. So you would just do negative x plus negative x squared plus 1. And that gives us negative x squared minus x plus 1. All right? So this function's name is q plus r of x. And I could do the same thing with addition and subtraction, multiplication and division. Okay? But there's another type of putting functions together called composition. And it doesn't use any of these. It's a new symbol, which is a small circle. Sometimes we replace the multiplication symbol with just a dot because we're lazy, or we just leave the dot off because we're really, really lazy. So a dot means multiply, but a small open circle means compose. Okay, so if I had g composed composed, let's try again, of f of x. Okay, that is the function's name, g composed with f, right? The instructions on how to build that is g of f of x. Okay, so what does that mean? Well, I want to write the g function, but how am I going to write the g function? In terms of the f function. So I'm going to stick the f function inside the g function. Okay? So what would g of f do? Well, we look at the f function. What does f do with Adam? The f function sends Adam to Castledale. What does the g function do with Castledale? Sends it to Santa Fe. And I do the same with all the others. So really, this is what's being done. Right? In fact, I can eliminate this and just do that. I skip the middle computation. So F sends people to cities, and G sends cities to middle schools. G of F sends people to middle schools and cuts out the cities in between. Okay, it's sort of a more efficient way to do it. So this is the name of the function, and this is the instructions on how we do that. Okay, so let's try to make sense of this. So R of Q of 5. Well, what does Q do to the number 5? So let's look at the number 5 in Q. It spits out -5. Okay, well, what does R do to -5? What happens if we put a -5 in there? So I get -5 times -5 is 25. Make it negative. -25 plus 1 would be -24. Okay. What about R of Q of 0? Well, Q of 0 is 0. And then I stick that into R, and I get 1. Okay? I'm doing a different problem. Yeah, I just made a new problem. So what about R of Q of 1? So Q of 1 is -1. What is R of -1? -1 times -1 is 1. Make it negative. Plus 1, 0. Okay? Now, I'm pretty lazy. Is there a way to do this in one step instead of 2? So, and put them together. Add is the wrong word, right? We want to put the 2 equations together. Well, what are the instructions? R of Q of X. And this is called R composed with Q of X. So I'm going to build a new equation. The name of that equation, this is supposed to be an open circle, is R composed with Q, or we say R of Q. So that's its name, and this is the instructions on how we do it. So we simply take this equation and we plug it in there, right? So the equation is this, but where the x used to be, I'm going to plug in -x. What is -x squared? Just x squared. So it becomes the opposite of x squared plus 1. Okay? Well, what does that do for me? Now, if I stick this in there, what should happen? I should get negative 24. Is that true? 5 squared is 5. Change the sign, add 1, negative 24. If I plug 0 in there, do I get this? I skipped the cities, right? Person 0 is going to school 1, and I skipped the city that they lived in. Person 1, plug it in there. 1 squared is 1, make it negative, add 1 is 0. And I skipped the city that they live in. Person 1 lives in city -1 and goes to middle school 0. Or if I want to skip that, I just plug in person 1 into the composed function and it spits out middle school 0. So let's look at another example. Okay. So R, nope, let's do it this way. S composed with R of X. So this is S with an R of X inside of it. So if I put R of X inside the S function, this is the S function, right? And the R of X looks like this. So that would be negative 2x minus 5 plus 1. So negative 2x minus 4. This is S composed with R of X. Okay? So what about when X equals negative 1? Well, what is R of negative 1? If I put a negative 1 in there, what happens? I get 3, right? Well, now, what happens when we put 3 in for S? It's the opposite of 3 plus 1, negative 2. So person 1 lives in city 3, and all kids in city 3 go to middle school -2. Okay? How else could I figure that out? I could just plug -1 in here. So -2 times -1 is 2, and 2 minus 4 is -2. That's how composition works. Okay? So for these problems, you don't need this equation. You can find it, but it's way more effort than you need. All you have to do is take -1, stick it into R, take the answer, and stick it into S. That's all it wants you to do. All right, domain of a rational function. Are there any numbers that I'm not allowed to plug into this equation? Anytime I get 0 on the bottom, so this factors into x minus 7 and x plus 8. So x is not allowed to equal 7 or -8. Okay. All right. So suppose that the function r of d dollars in euros is given by that equation 9 over 10d. The cost in dollars to purchase and ship n purses is given by P of n equals 99n plus 23. Write a formula for the cost in euros to purchase and ship n purses. So we're going to stick one inside the other. Okay? Which one goes into which? So why would you put R of D into P of N? Right, so what does this function do? It turns dollars into euros. So we have function R, and it takes dollar signs and converts them into, what is the euro sign? I don't remember. Something like that. Okay, so that's what function R does. All right, and what does function P do? So it's the cost in dollars to ship n purses. So it's going to take the number of purses and spit out cost, shipping cost, in dollars. So how am I going to arrange that? Am I going to put R inside P or P inside R? Well, if I went from here to here and then here to here, would that make sense? No, that doesn't make any sense. So I've got it backwards. So we're going to take, oops. We're going to take this stuff and move it over here. Okay. So how do I write that? Is that P of R or is that R of P? So which one has to happen first? P. So it needs to be on the inside. Are you confused? Oh, okay. Are you confused? The answer needs to be in euros, yes. But our shipping cost is in dollars. So we have to figure out the shipping cost in dollars and then convert that into euros. Because we don't know the shipping cost in euros, but that's what this function is going to do. Okay. So I need P to happen first. So P goes on the inside, or it would be R composed with P. And then P uses N. Okay? So another way to think of it is, what unit is this in? The answer to that. So if I have 10 purses, if I plug 10 in there, 99 times 10 is 990 plus 23 is 122. 122 what? Dollars. Okay? And I can only plug dollars in there. So the shipping has to happen first, which means it's on the inside. Does that make sense? So we are going to put this inside there, because this unit here is in dollars. So 9 over 10, and then 99n plus 23. Okay, yeah, let's do another one and see if we run into that. And we could simplify this, but notice it says don't bother, right? It would be kind of messy to whatever. It says you don't need to simplify. Okay, what if it was 3d plus 6? Then it would just be 3, where the d used to be. We're going to stick in 99n plus 23. Does that make sense? Okay, so the tricky thing is, you have to figure out which one is first, and that one goes on the inside. So R composed with P means, well, I guess it's N, means R with P of N on the inside. Okay, so if I did 5 purses, this would tell me how much those purses cost in dollars, and then this is going to tell me what it costs in euros. All right, let's look at another example. The braking distance for a certain car moving at velocity is given by that equation. The car's velocity in meters per second, t seconds after starting, is given by that. Okay, write a formula for the braking distance. Okay, so this is a distance in meters, right? What is this? That is the velocity. So am I going to plug distance into the velocity formula or velocity into the distance formula? I'm going to plug velocity into the distance formula, right? This is asking for a time, and this is asking for a velocity. So it has to be this with a 7t on the inside. So function b, if you give a time, it will spit out a velocity. So if you know 8 seconds in, how fast is the car going? If you take the velocity and plug it into the other equation, it will tell you the braking distance for that velocity, for that speed. Or the new function, the one I just built, will take time and turn it into a distance. So b takes time and turns it into a velocity, and function d takes velocity and turns it into a distance. What does this function do? It skips the middleman. Does that make sense? All right. Here we're just building a whole bunch of functions. So the first one, s times r of x, which is simply s of x times r of x. So 2x minus 5 times 3x. So 6x squared minus 15x. Okay, what does that do? Well, let's look at s times r of 1. How do we calculate s times r of 1? Well, I could do s of 1 and multiply that answer times r of 1. So what is s of 1? Negative 3. Right? So this is negative 3. What is r of 1? 3 for a total of negative 9. How else could I figure that out? I could put 1 in here. Right? Skip the middleman, essentially. So 6 times 1 squared is 6, and negative 15 times 1 is negative 15, so 6 minus 15 is negative 9. So functions don't care if you plug this number into each of those and then multiply those answers together, or you multiply the equations together and then plug in 1. You get the same either way. So how am I going to do this? Put negative 2 into s, and I get negative 4 minus 5 is negative 9. And I put negative 2 in here, and I get negative 6. And what do I do with those two values? It says take your s answer and subtract your r answer. So we get negative 3. How else could I have done that? Well, I could have taken s, 2x minus 5, and subtracted r, 3x, and that gives me negative x minus 5. And then plug negative 2 in there, and I happen to get the same answer. Crazy. I just blew Calvin's mind. It's not hard to do. Okay. Q of r of negative 1. So that is the name of the function. What are the instructions? Q with an r with a negative 1. So I plug negative 1 into r. What does that give me? Negative 6. What do I do with that negative 6? Stick it into Q. So that would be 24 plus 5 is 29. Okay, easy enough. Okay. What about the division of functions? So here we have a function whose name is g over h. Okay, and the variable it's written in is negative 3. So that is simply g, not q, g of negative 3 over h of negative 3. Right? So what is g of negative 3? Negative 3 squared is 9. 9 times negative 2 is negative 18 plus 5. So the top half of this is negative 13. Then I plug negative 3 into h. I get negative 27 minus 3 is negative 30. And that just simplifies down to 13 over 30. Okay? Are there any numbers I'm not allowed to plug in? Would 0 be okay? Could I do g of 0 over h of 0? Well, that would be 5 over negative 3. Is that fine? Yeah, that's okay. What do I need to worry about? I need to worry about h. Are there any numbers that would make h equal to 0? Well, let's just do 9x minus 3. That is function h. When is that function equal to 0? Add 3. 9x equals 3. Divide by 9. X equals 1/3. So this is not allowed. Okay? X equals 1/3 will turn the denominator into 0, and that will break the function. Okay? All right. This is kind of hard. How do we find the domain and range of a composition function? Oh, actually, this one's not too bad. Okay. So what does f do? F takes all of those people and turns them into cities. And G takes all of those cities and turns them into middle schools. Okay? So let's just follow them and see what happens. So if I wanted to do G of F, which one do I do first? You do the F first. So F takes 1 and turns it into 8. What does G do to 8? Turns it into 5. Okay? So now we look at 2. 2 gets turned into 1. So 2 gets turned into 1, and 1 gets turned into 9. Okay? 4 gets turned into 7, and 7 gets turned into 5. Okay? 5 gets turned into 7, and that also gets turned into 5. Okay? 6 gets turned into 3, and there is no 3. What does that mean? That kid doesn't get to go to middle school. Right? So what's really going on here? Well, what it looks like is City 3 must be in a different county, right? The only options we have for middle school are San Rafael and Canyon View. So where does a kid that lives in Wellington go? Somewhere else, right? Are they going to go to middle school? We don't know. All we know is they're not going to one of our 2 middle schools. So what do we do with that person? We just pretend they don't exist. Okay? And then person 8 lives in City 4, and City 4 doesn't go anywhere. Okay? Now, what about this? We never used that. What would that represent in our school analogy? Is it a new kid? It's not a new kid. A new town. Do people in that town go to one of our middle schools? Yes. So that town just must not have any kids in it yet. Right? So it's like Moore. Right? We have the town of Moore. Are there any kids currently in Moore that are attending one of the middle schools? According to this, no. So it's a town that would feed into San Rafael. But there are no kids in that town right now. Okay? So now we need to look at the domain and the range. What is the domain asking? It's asking which kids are part of this function. So looking at what we just wrote, which kids are part of the function? 1, 2, 4, and 5. What about kid 6? Does that kid exist? Yes. Does that kid belong in our function? No, because we're only looking at middle schools on this part of Emory County, right? So yes, person 6 exists, but they live in a town that does not feed into one of our middle schools, so we just ignore them. They're not part of the function. So the domain is going to be that. What about the range? All the middle schools that have kids in them. Okay? So 5 and 9. What about middle school 4? Does middle school 4 exist? Yes. Is it part of our function? No. Why not? No kids are there. Don't ask why. So our domain consists of all of the kids who go to one of our middle schools. And our range is all of our middle schools that currently have kids in them. We might have more middle schools out there that don't have kids in them, and we might have kids that don't go to our middle schools. So the domain is only those that start and have an end in the function. And then the range is only those that get hit by some kid inside the function. So this little symbol right here is set notation. So whenever you have that weird set of brackets, that means I'm about to give you a list of numbers. So the numbers would be 1, 2, 4, 5. I think that was a 5, right? Okay. So that is our domain. And our range is going to be 5 and 9. Do I need to put 5 twice? No. In fact, I could have just done that, right? And not write this the second time. So that's the idea behind it. We're going to get into what is the domain and the range of an equation that is composed, and that's a lot harder, but hopefully that makes sense. The domain is every kid that hits one of our middle schools, and the range is every middle school that has a kid in it. Okay, there are lots of middle schools out there, but they don't have our kids, so we don't include them. It could ask. Well, my guess is it's always going to be the same one. So it might, if this was f of g, then you would just do it backwards. So let's try that and see what happens. So let's try to make, it might not even work, f composed with g. So f takes the number 1 and turns it into 9. And what does g do to 9? Nothing. So that's out. 6 gets turned into 4. And 4 gets turned into 7. So that one exists. 7 gets turned into 5. And 5 gets turned back into 7. And 8 gets turned into 5, which gets turned into 7. Okay? So what is our domain? 1, 6, 7, and 8. What is our range? Oh, thank you. You're right. You're right. So our domain is 6, 7, and 8. What's our range? Just 7. And here is a kid that does not go to one of our middle schools. And then here are a whole bunch of middle schools that don't have any of our kids. All right. Was that the last problem? Yep. Okay. Get to work.